All right, so part 2, continuing on with this. So we said that all the letters in the complement of F in the second half were O, S, T, T, S, S, S. So first, if we have the probability of F given V, right? So what are the letters we're looking at? What are the only letters we're looking at? We're only looking at the V letters, right? So there's 5 of them. So out of V, which ones are in the second half of the alphabet? Well, just O, right? So that's 1 out of 5, which is 0.2. All right, part F. Oops. There we go, part F. So probability of V given the complement of F. So this time, right, we're only looking at the letters in the complement of F, which are 1, 2, 3, 4, 5, 6, 7. So out of all of these, how many are vowels? Just 1. So that's 1 out of 7, which is about 0.143. All right. So now let's move on to the multiple trials. So first things first, let's talk about mutually exclusive. So are V and C mutually exclusive? Well, yes, because there are no letters in common, right? Especially since there's no Y, we're not talking about a Y, right? So all these letters either are vowels or consonants, they're not both. Are C and F mutually exclusive? No, right? Why? So it's because there are letters in common with C and F, right? There are letters at the front of the alphabet that are also consonants. So because both include the letter C. So that's an example of something that you could write. Since both include the letter C, they can't be mutually exclusive. You could also say because both include some of the same letters. That also would work, right? They're not empty. All right. What about V and F? Are those mutually exclusive? And as you can see, once again, no, right? Both of them have an E, an A, and an A. So no, because there are letters in common with both. All right. Well, that's annoying. Let's just erase that. Good. All right, part T. If 2 letters are randomly drawn with replacement, what is the probability that both are from event V? So we have multiple ones, right? We're not just one letter, it's multiple letters. So then what do you gotta ask yourself? You gotta ask yourself, where's the and, right? We're gonna multiply. So how can you re-say this to where you go from a group to individuals, right? It's not just one group of 2 letters, right? They're 2 different letters. So another way to say it is tell me a story, right? Tell me the story of what happens. Go through the process. You don't just pick out 2 different, you don't say, oh, I just pick out 2 letters. That's not how this works, right? You pick out 1 letter, it's a V. And you pick out a second letter, it's a V, right? So we're looking for the probability of a V and a V. Oh, so you can also write it like this, right? First one's a V and the second one's a V. So we're going to be doing multiplication, right? First one's a V and second one's a V. Again, you don't have to necessarily write it like this. This is just maybe a good way to keep your notes, right? So that way when in the future, when you see it, you know what it is, but yeah, I don't necessarily need this. So what's the probability of getting a V? Well, there's 5 letters in V out of 17 total. And then since it's with replacement, we put it back, so there's still the 5 letters out of 17. So when you multiply those 2 together, you get about 0.087. All right. If two letters are drawn with replacement, what's the probability that they're both from C? So again, we have two letters. So what's happening? It's the probability of C and C, right? The first one is C, and then you pick out another one, and the second one is C. So what's the probability of C? Well, we said there were 10 letters in C. Nope, 12 letters in C, excuse me. So 12 divided by the total, which is 17. Since it's with replacement, we're putting it back. So another 12 out of 17. When you multiply both of those together, you end up with about 0.498. All right. Part V. Two letters are randomly drawn with replacement. What's probably that they're both from F? So again, we have two F's. So the first one is from F, and the second one is an F. So what's the probability that the first one's an F? We said it was 10 out of 17. Times, since it's with replacement, you put it back, so there's still 10 out of 17. When you multiply both of those, you get 0.346. All right, part F. If three letters are randomly drawn without replacement, what's the probability that all are from event V? All right, so again, walk me through what happens. So first time you do it, you get a V. Second time you do it, you get a V. Third time you do it, you get a V. So it's three different ones, right? V times the probability of V times the probability of V times the probability of V. So what's the probability of V? Well, there's 5 of them out of 17. Notice this time it's without replacement. So that means that we have less letters, right? We have one less letter, and that letter is V that we have one less of, right? So it's 4 out of 16. And then we have another one. So that would be 3 out of 15. And we multiply those all together, we end up with about 0.015. All right, so let's do the same thing, but with event C. So again, it's the probability of C and C and C, right? There are 3 letters. Each of them are supposed to be consonants. Probability of C, we said, was going to be 12 out of 17. Times, remember this is without replacement, so it goes down. So since we took one from the consonants, we have one less consonant. And since we took one from we took a letter, we have one less letter. And again, we still have one less, so that's one less C, one less letter in general. We multiply that together, we get 0.324 if we round. And then lastly, same thing, 3 letters are drawn without replacement. What's the probability they're all from F? So it's the probability of F, and the second one's an F, and the third one's an F. So we know that there's 10 in F, so that's going to be 10 divided by 17. Again, it's without replacement, so we're going to go down. We have one less letter in F and one less letter total. We have one less letter in F, one less letter total. So we multiply those together, we end up with 0.176. All right, part Z. I'm really moving along here. So if 3 letters are drawn, what's the probability that exactly one of them is from V? So remember, when we have exactly a letter, exactly some number of outcomes, we need to list out all the outcomes. So there's 3 letters. So what could happen? Well, the first one could be from V, and the second one and third one aren't. The second one could be from V, right? The first and third aren't. Or the last one's from V, and the first 2 aren't, right? These are the 3 ways that we can have where exactly one event is V. And notice we need all of these outcomes, right? This is a different outcome than this one, right? V occurring first is different than if V occurred second or third. So we need to talk about all the cases. So what's the probability that an event is from V? Said it was 5 out of 17. This is with replacement. So what's the probability that it's not from V? Well, that means it's either in the consonants or an F potentially, right? So notice if it is in V, there's 5 of them. So what are the ones that aren't in those 5? Well, if it's not one of the 5, it has to be the other 12. So we just have 12 over 17, and it's with replacement. So 12 over 17 again. And we multiply these together, we get about 1.4655-ish. We can see again, right, for the second one, if it's not in V, that's 12 over 17. If it is in V, it's 5 over 17. And if it's not in V, 12 over 17. And this is the exact same answer, right? This one is also going to be the same answer. So really, since we're adding these 3 numbers together and they're all the same thing, since there's 3 cases, we can just multiply this number by 3 in our calculator. So our final answer is 0.440. All right. The other way you could have done it, you could have just added these together by itself 3 times. You would end up with the same answer. All right. So 3 letters with replacement. What if exactly 2 of them are from C? All right. So if 2 of them are from C out of 3 letters, so we got to list out all the outcomes. So we have the first 2 could be from C. The first and last one could be from C. Or the last 2 could be from C. So the probability that the first one is from C, that's going to be 12 out of 17. It's with replacement, so the probability the second one's from C is also 12 out of 17. Probably that the last one is not from C, right? If 12 letters are in C, that means the other 5 aren't. And those are all the vowels, right? So 5 out of 17. When you multiply those together, we get about 0.14655. Huh. Yep, same answer. Yeah. So this is going to end up with the exact same answer. Ah, that's funny. Good. And again, you should see that this is going to be the same answer and this will be the same answer. So if we just multiply this by 3, we end up with 0.440 again. And we multiply it by 3 because there are 3 outcomes, right? The number isn't in the end, it isn't in the middle, or it isn't first. All right. 3 letters with replacement was probably exactly 1 is from F. So listing them all out, either the first one's from F, the second one's from F, or the last one's from F. So there's 10 letters in F, so we got 10 out of 17. So if 10 are from F, that means that the other, right, we can subtract it. Oh. There we go. So the other 7 aren't in F. Since it's with replacement, we're going to be 7 over 17, 7 over 17. When we multiply that together, we get 0.099735. There we go. This should be the exact same thing, right? So we can just multiply this by the 3 letters that we're doing, the 3 outcomes that we have, and we end up with 0.299. This time, if 4 letters are drawn without replacement, what's probably exactly 3 of them are an event V? So if 4 letters are randomly drawn, what's probably that at least 3 of them are from event V? So we have where the last one isn't in V, the third one isn't in V, the second one isn't in V, or the first one's not in V, right? So, first one being in V. There's 5 of them out of 17. Now notice, now we have without replacement. So, the second time, we already took out a letter, so there's one less letter, and that letter was in V, right? We took out a V, so that's 4 out of 16. Times, we took out another vowel, right? So there's one less letter and one less vowel. Now, we got to look at what about all the ones that aren't in V? So essentially the consonants. So we have definitely taken out another vowel the third time, so there's one less letter. But how many consonants have we taken out so far? None, right? They've all been vowels. So all the consonants are still there. So we have all 12 consonants still in the hat. So when you multiply those all together, you end up with 0.012605. We saw that these will be the exact same, right? So we can just multiply this by 4 because there's 4 different outcomes for this to occur. And we end up with 0.050. All right, part D. If 4 letters randomly drawn without selecting, what's the probability that exactly 3 are from event C? So what's the probability that exactly 3 are from event C? So again, we could say the first one is not from C, the second one is not in C, the third one's not a consonant, or the last one's not a consonant, right? All right, so if the first one's not in C, if it's not a consonant, then it has to be a vowel, right? There's 12 consonants, which means there are 5 vowels. And we've already talked about that, right? So 5 out of 17. Since this is without replacement, we already took out a letter. But what letter did we take out? We took out a vowel. So then how many consonants are still there? All of them, right? All of the consonants are still there. All 12. All right? So if you take out a consonant, that means we have one less letter and one less consonant now, right? Then we have 11 of them. And again, the last one, we have one less letter and one less consonant. So when you multiply those all together, we get 0.115546, blah, 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 blah. Right? These should also be the exact same, so we can just multiply that by 4, and we get 0.462. Part E. If 4 letters are drawn without replacement, what's the probability that exactly 1 is from F? What's probably exactly one of them is from F? All right, so that means that the first one is from F, the second one is F, the third one's F, or the last one's F. So if the first one's an F, right, and the probability is going to be 10 out of 17. It's without replacement, so now we have one less letter. But that one less letter, right, is going to be from F. So remember, the next one is essentially the consonant. That X, if it's not an F, it's in the complement of F. And we haven't taken any of those, right? We haven't taken any in the second half of the alphabet yet. So all of those are still intact, all 7, right? We haven't taken out O, S, T, T, S, S, or S. We've only taken one of these letters. So all these 7 are still intact. So there's 7 out of 16 that we can take. If we take out one from there, then we have one less letter and one less letter from the second half of the alphabet. So there's 6 of them. And again, one less letter from the second half of the alphabet, so 5. When you multiply all that together, we end up with 0.036765, blah, 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 blah. And again, all these are going to be the exact same, so there's going to be 4 of them, so we multiply that by 4. We end up with 0.147. All right. last concept, and then we are done with Chapter 5 reviews. Woo! All right. So, part F. If 3 letters are drawn with replacement, what's the probability at least one is in V? So at least one. So we got to do our 4 steps. Step 1, L. L means at least one in V. So then step 2, the complement, right? So that's none in V. So if none of them are vowels, what does that mean? They're all what? All consonants. And how many consonants? All 3 of them are consonants. So let's find the probability of that, right? So the probability that all 3 are consonants. So there's more than one, so now we're going back to that multiple trials. So it's the probability that the first one's a consonant, and the second one's a consonant, and the third one's a consonant, right? Tell your story. I pick out a letter, it's a consonant. Pick out another letter, it's a consonant. Pick out another letter, it's a consonant. All right, so the probability of the first one being a consonant is 12 over 17. This is with replacement, so it's also 12 out of 17 and 12 out of 17. So we multiply that together. We get about 0.35172. So lastly, we know we just got to do 1 minus the complement to get our final answer. So 1 minus 0.3571. And we get 0.648. So that's our final answer, 0.648. And you'll see that every single at least one problem, if you know those 4 steps, this is it. So, part G, 3 letters with replacement, at least one from C. So step 1, L means at least one of 3 from C. Step 2, complement means none of 3 from C. So if none of them are in C, then all of them are vowels, right? So all 3 are vowels. So let's find the probability that all 3 are vowels. Well, since we have more than one letter, right? That means the first one's a vowel, and the second one's a vowel, and the third one's a vowel. So probability that it's a vowel, it's 5 out of 17. It's with replacement, so the second time it's also 5 out of 17 and 5 out of 17. We multiply that together. We get 0.025443. And then the last step, the probability of at least one is 1 minus the complement. Which is 0.975. All right. 3 letters with replacement, at least one from F. So once again, step 1, L. At least one of 3 from F. Step 2, the complement. None of 3 from F. Step 3, probability of the complement. So if none of them are in F, then basically all of them are going to be in the complement, right? So we know that the probability that all 3 are from the complement. And we've already talked about the complement is O, S, T, T, S, S, S. Which means, of course, that the first one's in the complement, and the second one's from the complement, and the third one's from the complement. Right? The second half of the alphabet. Well, we can see that the probability that of the complement is going to be 7 out of 17. Since it's with replacement, it's still 7 out of 17 and 7 out of 17. When we do that, we get 0.69815. And then the probability of at least 1 is just 1 minus that complement, which is 1 minus 0.069815. So when you subtract and round to 3 decimals, you get about 0.930. All right, double I. 2 letters without replacement, at least 1 from V. So again, same 4 steps. L. And this might feel monotonous. Why do I have to do this? You absolutely don't. But if you follow these 4 rules, right, these 4 steps, it's the same every single time. You can't do it wrong. At least 1 of 2 letters from V, right? That of 2 is important. It'll help us out with the step 3. So the complement means none of 2 from V, which of course means that all 2 are from C, right? If they're not vowels, then there have to be consonants. So the probability of the complement, which means the probability of the first one being C and the second one being from C. So the first one is 10 out of 17 times. Now notice this time it's without replacement. So we have 1 less letter. And since the first one was from a consonant, we have 1 less consonant. So it's going to be 9 out of 16. All right, when we multiply that out, we get 0.330882, blah, blah, blah. So the probability of at least 1 is just going to be 1 minus that step in step 3. So 1 minus 0.330882, blah, 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 which is about 0.669. Last 2. So 2 letters without replacement, at least 1 from C. So L, at least 1 of 2 from C. Number 2, the complement, none of 2 from C. So neither of them are consonants, which means that both of them are vowels. So the probability of the complement, we know we have the first one's a vowel and the second one's a vowel. So the first one's a vowel, that's 5 out of 17. It's with replacement, or sorry, without replacement. So we have 1 less letter, which is 16. And since the first one took it from a vowel, we have 1 less vowel as well. So now we have 4 out of 16. When we multiply that out, we end up with 0.073529. So last step, we do 1 minus that. And we get about 0.926. Last problem. So, last step. If 2 letters are randomly drawn without replacement, what is the probability that at least 1 is from event F? So, we got at least 1 from F of 2. So the complement's going to be none of 2 from F. So that means that they're all in F, in the complement of F, right? Which again we said is O, S, T, T, S, S, S. So the first one's in the complement and the second one's in the complement. So first one is going to be 7 over 17. Since it's without replacement, we're going down on both. So 6 over 16. When you multiply that out, 0.154412. So probability of at least 1 is going to be 1 minus the complement, which is 1 minus 0.154412. So we get about 0.846. And that's it. All right. So as always, if you have any questions, definitely let me know. Otherwise, you have an absolute great day.